So John moves next. He obtained his PhD from NC State, and he's worked in the field of genomics and bioinformatics since 2001. At Omicsoft, he leads the data curation and data analysis teams for our data services, including CVMLand and ImmunoLand. And his team has processed over 20,000 samples for ImmunoLand, including thousands of RNA-seq samples from GeoArray Express and the Sequence Read Archive. And we plan on expanding that as he's about to demonstrate now.
The previous presentation, Jason has gone over the ImmunoLand. So I will start my presentation with a very brief update on ImmunoLand and CVMLand. CVM is that stand for cardiovascular and land. So then I will continue with some introduction about our land data product pipeline with the focus on data curation, because previously we already have a primary user applications on each single step on data process, but our method curation and navigate not quite attention, so there are a lot of opportunities in this area. So I think that's the one of the major sections. I will discuss how these data are created. Then I will continue with the single cell land. Today we have from disease land. Disease land started with internal story, including both ImmunoLand and combined for disease land. And then finally will be the roadmap for our development efforts. So now I think for ImmunoLand and CVMLand, the difference from ImmunoLand is mainly on those disease categories. All those underlying data storage structure, many of them are exactly the same. That's why we really integrate different projects from different lands or from these different projects for the virtual land. So exactly these underlying structures are very same, and also the interface are very similar. However, the projects are different. So you can see that ImmunoLand mainly covers these areas, including arthritis, autoimmune disease, infectious disease, COPD, and many of the neurodegenerative diseases, including Parkinson's, metabolic disease, etc. And also we have some skin-related like arthritis disease. And for CVMLand, sure that cardiovascular disease will be a major section. And then you have fatty liver disease and also many of the diabetes and in fact obesity also related organ disease. So there's a major section for this project. These slides show you the latest collection of the data we have for our 2016 quarter one, which we have already finished and it's going to be. So we have for ImmunoLand, both human and mouse, we have probably 600 plus projects for the human and 200 projects for the mouse, and including both RNA-seq samples and also micro samples. So overall, there are probably close to 50,000 samples in ImmunoLand, the latest versions. And also, we have more than 2,500 comparisons that mostly different projects in the ImmunoLand. And the CVMLand, in fact, we did this at the end of last year. So at that time, the project was still limited, but the recent quarter, pretty much triple the amount of projects we had in the previous release. So we add more than 10,000 examples into CVMLand. So right now, the product has more than probably close to 17,000 samples in CVMLand. So generally, we can process probably 150 to 200 projects per quarter for each land. So both CVMLand and the ImmunoLand, we have more than 150 projects into each land. And then that numbers we have that's probably about 5,000 to 10,000 examples. And also usually we get more IMC projects that increase the numbers a little bit. IMC projects include some platforms. And then we push out more for great projects, for great projects. This is the land tissue distribution for different lands for both ImmunoLand and CVMLand. And this distribution is quite related, it's close related to what we did studying in ImmunoLand. We have a lot of tissues from blood and also from respiration system and also some sections. I think this is from central nervous system. And then for CVMLand, we have show you still have a lot of samples from blood, and then there's some major sections for these active tissues, more fat tissues, and then you have a lot of liver. And this is the cell type distributions. You have most of them have a lot of immune cells, T cell, B cell, etc. And then epithelial cells, ImmunoLand, and also neurons, ImmunoLand, and then for CVMLand, we also have epithelial cells and also a lot of yes. So I think next I will switch gear to discuss the processing workflow and for detailed usage introduction about how to use CVMLand and also how to use ImmunoLand. I think the breakout sessions in math and again we're going to have another discussion. So I will show many usage slides here. So for processing workflow, we start this whole process by selecting data sets. Most of them have to the disease area related, and then we select the ones to classify our time. And then these projects will be trained, and also we feel that some of the projects which are not, they are not really available. And then we have scripts to download the raw data and metadata from these original data sources. The metadata will be through this curation process, which I will elaborate in later slides. And then these raw data will go into our data processing pipelines for micro data sets, or usually they will go through the signal instructions, extract the code level informations, levels, and then for amnesic, usually those downloads directly. Again, the factory file available, we always have the factory our aligners to realign these to realign those beats and generate background internal summarization is trying to summarize them into gene level and transcript level. And then these things will go to QC. And after this metadata was curated, our internal statistician will take these metadata and try to build up those statistical models, consider all those batch effects, all those treatment effects, and then these statistical models will combine with the raw intensities or raw gene level, expression levels, and these will be used for generating comparisons. Then we have post-analysis QC. You always want to check your analysis. Those after these analysis and those validation steps, these comparison results we are going to land, and also if you already normalize raw intensity value, normalized intensity value will also go to land as well as metadata. So for the metadata curation step, we start this process by selecting projects, and then we have those internally developed scripts or fancies using keywords to extract the data, metadata from the original sources for both GDO and Express. And these projects are filtered to, for example, there are a lot of some of the platforms do not support arrays and some very obsolete platforms really these projects that are values. And then some of the projects probably have some keywords, but they have nothing to do with it, so we really back them out unless some clients do. And these metadata will be curated, will be exported to a raw design file and move on to later data curation. And the goal of our metadata curation, in fact, was we're trying to achieve the metadata homogenization across the you always have that effect for sure, but at least we want to make data more comparable across the projects. So these metadata this is a detailed step-by-step curation process. We start automatically generate the design file. Start with assigning the design file to domain experts. We always believe the person who really works at those projects is more important than the who you decide to start to work with. Probably is more important than the program. Whatever program you write, how good your computer algorithm is to do the whole validation. But the person create data set, the only job that will end up probably with worse results. So each project will be assigned to multiple curators. Generally, we assign each project to at least 2 curators. One is internally, the other is outside our office. These data sets in the project. So after these curators receive these projects, they will curate this data set both at sample level and also project level. We use our internal standards, and then curate results will go back to our internal curator. And then if there's all these problems or errors, we'll kick back ask these curators to modify these results, and then they will sometimes go back and forth several rounds. These results are acceptable. And then these curated results from different curators will go to our internal merger. We have to merge these different curation results from different curators, and then make sure that we do have consistent curation of our different versions. Somehow, 2 or 3 curators are not showing the same curation. Take another look to make sure everything is formed is right. Then finally, these merge results will go for independent internal curator for another check and validation. So overall, it's a lengthy process. It's very tedious. I think Matt really previously I think he's doing the same thing as anybody. We have discussions with our sites. A lot of people are doing similar things internally. We have some but we start with using probably one person curate things to find out that random errors happening, especially typos, updates, always, just all over the place, and we have to come we would rather take some pains at our side to make sure the system delivers as can. So the curation standard control vocabularies we use are from very various fields, including, for example, the cell type, we use OPO cell ontologies, and also for disease, we use previously MASH, but now we call both MASH and OPO-ID. We have MASH very strong to sometimes you can't find the MASH in their system. And then for tissues, we use the overall. Previously, we used another one, but they are somehow. A lot of these control vocabularies are maintained by Omicsoft projects, or sometimes it's on a project, people start in the embedded, update their control vocabularies. So that's why we maintain our own control vocabularies. Sometimes these are the control vocabularies are back reference to all these major sources. Help us to maintain a very stable control vocabulary, and also help us to and for many of the fields or columns, there's no complete control vocabularies, public control vocabulary available. So we study different data sets, trying to come up with something of our own. These sources can be from primary articles, can also come from a lot of geo studies. And then all these control vocabularies will be maintained by our internal managers, and then we make sure they are all documented, and our outside curator, our internal curator, also use them properly. And the curation standards, usually the automatically extracts metadata, they will have some sort of curation, but it really, the quality of them really varies project by project. There are some projects which have very good annotations, especially those that are from certain consortium, but there are also some projects with minimum information. For these, for data already, we have the automatic extract data, we try to format them to these our internal creation libraries, column names, and then for sure we always go back to our original automatic extraction metadata. And then we have those required columns for many project level. For example, at project level, we require us to add our curators planning therapeutic area, disease, project level disease, and also at sample level, we require that each sample should have a tissue application and also have disease state annotation. And then for cell-based studies, you should have a cell type annotation. In case you receive some treatment, this treatment is also. And there are some other required information is land specific. For example, single cell land, we go out pretty soon. They will get when need. How do you purify or isolate those cells? So those are cell specific, and also for mouse project, we require those mouse project as those one mouse project has animal strings. There are also some projects which is disease specific, so we will add that as well, and then you have those platform specific metadata, for example, library type, those separation methods, and also some projects has ERT also. This is a slide showing you our internal curation tool. So I think this curation process is very tedious work. I'm a bioinformatician, I don't like to do that. I think that's how it really works. Yeah, but that's very important. We do need those in the right conclusion, where emphasis for the routine changes, etc., and also project. But the good thing is that we are software company. We develop some tool and try to help our curators and also help our colleagues. So this is some screenshot showing you that these features of our curation tool. So the raw design file, format, and the Excel format will be loaded to our curation tools. Then we use list of these. You can easily select those column names from existing column names so that it can be used whatever column is as much as possible. And then in case there's an upcase and lowercase, and you have some or one, you have some where it is, will duplicate information. And then we always list the original sources. It's not like we modify directly on that file, so we always have new curations aside with what original product reference here, so that we don't accidentally remove some information so later on we cannot find what are these examples, what's the previous value. So we start the curation new, and then these during the merging side, we might have original reference, we have the curation, curating the result, curating the result from curation 1, the result from curation 2, and side by side, easy for the entire person to check what kind of values you might have. And then for the control vocabularies we use, you can see that we have maintained these control vocabularies. Not only provide a term, we also provide a synonym and also detailed description for vocabularies that can help us easily match things, to easily help us, our curators, find out the perfect word to use instead of getting around what we write. So that's the curation tool we use. And then these analyze the metadata will be exported by this curation tool and it goes to our analysis pipeline. Any questions at this stage? Move forward. Single cell land. I think this is single cell sequencing is a very hot user area in the last years. I think we started doing this from late last year. Really, the mass processing in fact happened we get several requests from different clients and ask us when we can work for that. We do get a request, so we move very fast trying to generate single-cell lens for our users. And it's so for the single-cell sequencing, this is a slide I steal from Nation Methods. So basically showing you a diagram of the steps that how the single-cell sequencing was done. So our single-cell lens mainly focus on the single-cell RNA. Then DNA sequencing will probably follow later on the later stage. So for the single-cell lens, it can help us to find out molecular fingerprinting at a cellular level. It can also help us to passive gene instruction on phenotypic variations. And also there's a lot of applications and also identify the real cell populations. Can also help us to do tumor and immune system microevolutions. So at this stage, we have already aligned more than 13,000 samples from the 35 genome projects, and this is a very diverse, data set. You can see that the platform can have SMART-seq, you can have PCR, or using QC, or with the textual libraries, and we have quality, CLC, QC. We have a couple of jobs here. Really, everyone understand that the project to get from zero always ready until people can publish. They won't be out of the data platform. So with the time passed by, you will see much more examples and use them. And also for single cell sequencing projects, usually each project probably have from I think close to 100, sometimes some larger projects have thousands of samples. Easily push out these sample numbers very quickly. So I think during the release time, we are still processing this. During the release time, this number will go much higher. After we add it to the project. And also, these single-cell lens covers very diverse cell types. You have the bone marrow, the nerve cells, you have stem cells, you also have fibroblasts, and also large. At this time, I think we are actively doing QC and also just also trying to generate tools and also generate those generate those gene level testing signal information for our land. I just show you some of the QC results we have, and from the projects we have already gotten. You can see in general that this is a log 10-base scale, so log 6 is 1 million of reads. The majority of the study has achieved that. But the problem is the coverage is generally low. The majority of these studies have coverage only 20%. There are some publications and also I think the latest review from genome biology and saying that they claim that I think there are some studies saying that really 1 million of reads for single cell is due to the sequencing more cells rather than sequencing people. But we did some training study to show that really these reads does have very low coverage. If you increase that's for sure the coverage will at this time it's only 35 projects, and some of the projects now we are biased because of the some projects where we have huge numbers of environment. We deviate the whole conclusion, so that we don't want to put too much emphasis on that, but in general that's where we find from the number of data we have already got. And this is alignment rate. You can see different cell types showing very diverse alignment rates. There's majority of them, in fact, there are alignment rates overall. For example, you have probably 0.6, 0.8 alignment rate, but there are always some more aligned with really those problems, some of that cells that they can use as one of the criteria to get out bad cells. And also, it's well documented that mitochondrial, the amount of standard rate aligned to mitochondria can also be cell is broken, you will see something like this, a huge amount of alignment rate on mitochondria. So those can be used as another criteria to get results. Generally, we see that majority of products has lower than 10% of reads back to mitochondria, except one project, which is high. But overall, I think these results still quite good. And quite some of the single cell projects splicing, including the ERC splicing, but there are also some projects using plant sequences, some other applications, but most of them use ERC splicing. And I think the percentage of reads aligned to splicing, and also the percentage of reads aligned to genome, and also the percentage of reads aligned to overall and combined together. That ratio can be used as these bad cells. And you can see that, for example, if you have almost one for this cell, if you have over 1% of that master splicing, if you give us these slides, I copied that from Nature Genetics. It's pretty much a comparison of the bi-cell and single-cell sequencing for the analysis strategies. So you can see that many tools can be used by those strategies. For example, the alignment tools, we use Omicsoft alignment for both those for part sequencing strategies and work strategies as well. So that's good enough. And also, but the QC steps, and also especially the normalization steps, are quite different. It's well known that the single cell accuracy is 0, right? Which is really affected by normal distribution, the signal distribution, but those single cell accuracy for the zero iteration, so different specific model. We are in the active development mode to develop tools to help us to processing our public single cell sequencing project. Not only because of we generate the data, but I think many of these tools will be helpful for our users to process their own data as well. So we generate tools to summarize the QC from the company, language, etc. And also many can see this trend more and more projects that are new online. So you need tools to be much effective for these kind of studies. And also normalization is different. We use develop new tools to normalize based on the spectrum. And this is very important for to study transcriptional edits, because the previous assumption that you have the same expression level or different scale. And also, I think downloading gain some popularities, so that's another tool for you. Well, for sure we need to tools to summarize function using. I think the active development, most of the tools already are available. And another major thing we want to tackle is differential gene expressions. We are evaluating different tools, but at this stage we probably will want to use the analysis. And some application-specific tools, for example, I think we do get some requests after that's what we are doing right now. So that can help us to do reduction and also use that in data. This tool in fact is not able we are also looking into different tools for cell type and subpopulation identification, cell applications, those IDs, and identifying highly variable genes and also study the transcription kinetics. So the idea is not only to push out the data that we can use, but also implement some tools that we can start for the own data analysis on the data analysis. So this one is the roadmap for our future development efforts. We have the single cell land, which I have just gone over before, and then we are actively doing development on evaluation land. I think Jack has already introduction on the encoding, so project to release that. The first training is probably where we have around the third quarter. Then microRNA and other non-coding RNAs is will be added probably at the end of this year. And then chipseq and methylation will follow. And the data sources, I think we already have a pipeline for ReExpress, but ReExpress is more difficult to analyze, more difficult to create than projects from GO. So previously our major efforts was trying to get data from GO as much as possible, but there are some very useful ReExpress, so we are going to add a second project that data source as well for sure. We are always looking for more. I think for ImmunoLand, I think many of the things we already released recently soon, and also for our CVMLand and also for ImmunoLand, we are going to release these 38 lessons. So this is going to release a parallel version. So we will have both 37 and 38 for human projects. Also, we keep updating our metadata, including these specific controller libraries, etc. So will be updated as well, and trying to add more analytical tools and also use to better utilize the data we have. So finally, I will thank, first of all, I will thank our customers and our collaborators. There's a lot of information and feedback our initiative was pushed by our customers. We send out requests to have this and keep trying to and add value to our people. So if you have more requests, just really contact our support team or requests. And also, I would like to thank our curation team, the land data processing team, and also the development and support team. Without them, we are not able to have a product. And specifically, thanks to Chris, who's in charge of the data curation team, and also Yang, Ken, and Jai, and these are key members for our data processing and also some of the development team as well. And for sure, our contractors. Now that we will have to now. They all will come to us. With that, I will ask Michelle, questions on that. Any questions? We got an extra 10 minutes break. Are part of other lands or separate? The single cell land will be included, at least provisional release will be part of the release land. If you have subscription for CVMLand or ImmunoLand, you get it for free. But right now, for people that are only have an unrealized subscription, we are also interested in single cell land. This question goes
So just to give you guys some summary of business model, so we're going to have basically three types of land. ImmunoLand is that which includes UGM and CVMLand, and ImmunoLand for genetics. So for genetics land, we actually have at least two actually extra type of land inside. One is single cell land, one is ImmunoLand. So and then for ImmunoLand, if you are interested in these two new lands, we have actually so I really planning it, but that's something if we actually think of think about it, I think there will be some way to get around the email and CVMLand to get that. But I think the good news that we have to be is that we're not going to have like 4, 5, 6. If you have a new disease area, we'll try to actually fit into either ImmunoLand or UGM or CVMLand. If you cannot fit, you automatically go to UGM. So no more additional land from Omicsoft in the future. But that is a different animal. Higher level data, but a lot of computing from Omicsoft process and one-time data, right? So that's that's not automatic.
Technology-wise, maybe it's probably 30 minutes that we try